So the function is not defined at 1. Great job. Good. I already know that x equals 1 is a VA. Because I found the slant asymptote first, I don't have to calculate the limits anymore. The function must follow the slant asymptote. I'll make myself a note, y equals x plus 1, slant asymptote. Now, so let me copy the function closer here. I have to plug in 0, but 0 over -1 is 0. And now I also have to find these limits, and then I'm done here. There's nothing else that I can find about the function from the function itself. So 1 from the left. The top is positive. 1 from the left with 0.9. Can anyone give us this limit? This is 0.9 minus 1. The top is positive. What will be the limit from the left? Say it again.
Or negative.
Perfect. What about this side with 1.1?
That would be infinity.
That's it. We're done. Now I'm ready to move on to the first derivative. I'm going to copy the function here, y equals x squared over x minus 1. So we want f prime or y prime is the same thing. What rule applies here? What rule of differentiation we apply here?
Quotient.
Perfect. Very good. So then the top prime is 2x times the denominator minus the top times the denominator prime. Yay, it's 1. And then I have x minus 1 squared. Please, I caution you again and again. I've seen it in your work. I've seen this being simplified. Please don't do that. It's not allowed. X minus 1 is not a factor at the top. We cannot simplify, please. I cannot factor anything. I wish I could. That's my target always. Factor, factor, factor to simplify. But I can't because there is no common factor. I mean, I could. X, actually. I saw that. So let's factor out x. So I have 2x minus 2 and then minus x. I always look to simplify because then I have to factor out anyway because I'm looking for critical numbers. So I see an x here. So then I have 2x minus 2 and then minus x. So always try that. So 2x minus x, so I have x minus 2 divided by x minus 1 squared. Again, we never expand factors in the denominator. Please never touch the denominator. Leave it alone. We don't want the extra work for nothing. It's not going to help. So now I'm looking at f prime of x being 0 or undefined. But this is undefined where the function is undefined. So it's not going to work. We're not going to get critical numbers coming from f prime being undefined. But what are the options for this function to be 0?
The numerator would be 0.
Good.
So x would equal 0 or 2.
Excellent. Back to the table. 0 and 2. I have to plug in 2 in the function. Every time I put an x value, I also have to find the y value immediately. So when I plug in 2, 4 over 1. 4 over 1 is 4. Now I have to study the sign of the derivative. Which piece from here you will not even look at? X minus 2, or x minus 1 squared? For studying the sign, which piece you'll say I'm not going to waste my time with? And why? Anyone?
Could you repeat that question?
Yes. So I have three factors. I have x minus 2, and x minus 1 squared. And I'm trying to study the sign of this expression. Which factor I will not waste my time to study the sign of?
The denominator.
Of course. It's a waste of time because it's always positive. It's not going to make any difference. Good. So in x times x minus 2, I will plug in negative 10. What is the sign? Then I will plug in, I can even plug in 1. It doesn't matter. The sign. And then with 10. So with negative 10, what do I get? Just the sign. I don't care for the number. Then you can plug in 1 because we're not plugging in the denominator. And we can plug in 10. I need the sign here, and the sign here. With negative 10, what do I get?
$120.
So the sign is positive. That's all I care about. So when you plug in 1, what sign do we get?
You don't.
1 times 1 minus 2. What sign do we get?
Oh, negative.
Perfect. And now let's plug in 10. And I need the sign.
Positive.
Exactly. At this point, this is the moment of truth. If these two rows do not go in sync, I'll say stop, stop, start from scratch, do it again. Something is wrong. Okay, so let's see. From negative infinity to 0, what does the function do?
Increase.
Is that supported by the sign of the first derivative?
Yes.
Perfect. From 0 to negative infinity?
Decrease.
Perfect. Is that supported by the sign of the first derivative?
Yes.
Perfect. From positive infinity to 4?
Decrease.
Perfect. Is that supported by the sign of the first derivative?
Yes.
And from 4 to infinity?
Increase.
Perfect. At this point, I'm able to identify what type of point is 0, 0.
Maximum.
Very good. Relative max. What type of point is 2, 4?
Minimum.
Relative minimum. We're done with this. We're done with this. However, because there is a maximum here, what do you expect the sign of the second derivative to be?
Negative.
Yes. Yes. It's not a big function, so we can do it. But if this is our second derivative test, because the function has a maximum, the second derivative has to be negative so that the function looks like this. Because there is a critical number, otherwise it's more difficult to identify. What happens here? What do you think the sign will be here? When there is a critical number and we know it's a relative minimum, what will the sign of the second derivative be?
Positive.
Yes. So we expect this and we expect this. But let's do the calculations. So our first derivative is x squared minus 2x over x minus 1 squared. I don't want to have a product at the top. I want to distribute. And now let's find the second derivative. And I am on page 7. So the second derivative, x minus 1 to the fourth, I have to use the quotient rule again. Can anyone give us the top prime? The top prime.
2x minus 2.
Very good. Thank you so much. X minus 1 squared minus x squared minus 2x. Now, can anyone differentiate the denominator? And I'll put it here. So we are differentiating x minus 1 squared.
2x
2 times x minus 1 to 2 minus 1, which is 1, times the inner function prime, which is
1.
exactly. Please factor, please factor, please factor. Do not distribute. Please do not distribute. Very important to remember, please. So I have at least an x minus 1. If I factor out a 2, I will do that too. So 2 x minus 1 times x minus 1 squared minus x, so 2 in front, x squared minus 2x, and x minus 1. So I put the 2 in front, I copy this, and I copy this. And here I factor out a 2. So I have x minus 1 and then x minus 1 squared. And everything is over x minus 1 to the fourth. Do not attempt to simplify anything, please, at this point. So I see that I can factor out a 2, and I can factor out an x minus 1. So I will do just that, 2x minus 1. After I factor out, now I can simplify it, not before. So this is left in, but I know how to square. It's x squared minus 2x plus 1. This is gone and this is gone, but I have a minus sign to be distributed to these two. So minus x squared, but plus 2x. So gone, wonderful. Gone, wonderful. 2 over x minus 1 to the third. This is never 0, so there are no inflection points. But I have to study the sign. So here is, in my mind, how I study the sign of 2. Yes, you can plug it in the graphing calculator, but why? Let me just show you the trick, that little trick that I'm using. 2 over x minus 1 squared times x minus 1. You don't have to write this, but just bear with me. 2 plus 1 is 3. But I refuse to study the sign of this. It's a waste of time. I will only study the sign of x minus 1. Because this is always positive. To the left of 1, this is negative. To the left of 1, this is negative, as we already expected. To the right of 1, this is positive, as we already expected. Why? What helped us determine this? The maximum and the minimum. Of course, everything is gibberish. I don't care. I don't need anything else. This is the only thing I need. So, and of course the function is not symmetric. I should write here. F of negative x does not equal f of x, and it does not equal negative f of x, meaning the function is not symmetric. How do I know? I don't have to calculate anything. It has a vertical asymptote at 1. It will never be symmetric with respect to anything. Good. So this is x equals 1. So now I start with the points. The first point I have is 0, 0. And the second point I have is 2, 4. Then I have to continue with the slant asymptote. I always graph the asymptotes before I graph the function. It's not going to be a solid line. It will be a dashed line like x equals 1. How do I graph x plus 1? Very easy. When x is 0, y is 1. Let me use a different color on this. And when y is 0, x is negative 1. So we have a vertical asymptote x equals 1, and we have a slant asymptote x plus 1. Back to our table. Ready? It's coming from negative infinity, of course, close to the asymptote. It must be. Increases to 0, 0, opening down, but then it starts decreasing towards negative infinity on the left-hand side of the vertical asymptote. Very nice. Following it asymptotically, getting closer and closer, not touching it, getting closer and closer, getting closer and closer. So from negative infinity, from close and close to slant asymptote, increasing to a relative max at the origin, and then it starts decreasing, still opening down towards negative infinity. Done. The other side. Coming from positive infinity, dropping to opening up, dropping to 2, 4, which is a relative minimum, and then increasing towards infinity, of course, approaching the slant asymptote. Not here this way. No, it has to follow the slant asymptote. So it's coming from positive infinity. It drops to 2, 4, and then gets closer and closer to the slant asymptote, going towards infinity. Always opening up, and on this side, always opening down. So this function, very nice pick, x squared over x minus 1. It was a very nice exam. Thank you for choosing that. Any questions on this? Any questions, please?